If you have not attempted it, go ahead and work on it now. It's homework. It's due by 5 p.m. today. That's why I give you till 5 p.m. so you kind of have class periods to work on it as well. So you can be working on it. But for the rest of you guys, you've already started and maybe you've already gotten stuck, or maybe you worked all the way through it because you got it yesterday and you already have very clear questions. So I am ready when you are. Let me grab my little beep, beep, beep guy out and I'm ready to go. What do we have? 2? Yeah? Okay, sorry. I just need some sort of affirmation because I didn't quite hear it. It sounded like 0 for a second. Number 2, an estimate. Oh, I love these. Guys, what did I ask you yesterday to put in your forever card underneath the definite integral and FTC? You guys know what I'm talking about? Yeah, area. Whenever you see a definite integral from A to B, or even an integration as net change, you could put it there too. Whenever you see, I'm trying to expand your understanding of what this is. You should know it's area, but that's okay. Write it in a forever card. Area under f of x, whoever the integrand is, right? So can we reword this question to say, estimate the area under f of x from 0 to 5? Okay, so how do we estimate area? Do you want to start making rectangles and triangles and semicircles? You could, but what else could you estimate, guys? What's that? A square with an area of what? Okay, I have multiple people looking. What's the area of the square? 5. 1 times 5, base times height, right? So wouldn't this be 5? How many of those do I have? 5, 10, 15. Well, if you want to, check it. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, right? What can I automatically say? Well, forget those two. If you want to, you can just count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm not done yet, right? Couldn't that be 14 if I maybe take that little piece with it? Couldn't this be maybe like a 14, 15-ish? Couldn't this be like a maybe a 16 and a half-ish? I don't know. Maybe 16 and a half-ish? Or if you want to keep on going the way we were, every 2 is 10. So 10, 20, 30, 40, 50, 60. Oh, that's rough. Sorry. 10, 20. I lost my train of thought. 10, 20, 30, 40, 50. There we go. 60, 70, 80. 80 and a little bit? I would go 80C. What did you guys get? Oh, okay. 95 would need like a whole nother 3 boxes. 100 would need a whole nother 4 boxes. And these ones aren't even close. Are we cool? Okay. So what was the key to this problem? What would you guys say? Area. Yeah. Is that cool? All right. What else do we have? Number 4. Number 6? 4, 6, 7? Number 4. Use the data in the table. Oh, sorry. The data in the table represents the rate. Ooh. I would circle that. The data in the table represents the rate of light output of a flashbulb at a given time. Using a with estimate the total light output of the bulb. Do you guys realize that? Measured in million lumen milliseconds. I see a 1 and a 2 and a 3. A proper AP question should have said something for t within 0 to 30. I apologize, it didn't say that. It should tell you where to go. So if I'm going from 0 to 30 in 3 jumps, and I need to have a middle, I need to have a middle for my midpoint. But real quick reminder of what we're doing. I'm going to call this L of t. Millions of lumens, the rate. Ooh. Sorry guys, there's a typo in your packet. Can you guys go ahead really quickly? There's a typo in your packet. Can you go ahead and put per? Millions of lumens is the light output, but this is supposed to be a rate according to what I'm reading. Oh, no, it is okay. This is one of those nasty ones that our brains don't really fully comprehend without going into the physics. Never mind, that's right. we're putting in the rate and we're getting out the quantity. We're getting out the output. We're putting in the rate and we're getting out the output. As we always do, we put a rate into an integral and we get out the actual value. So that's ultimately what we're doing, and we're able to do that by, now it's going to be between 0 to 30, and the output is going to be, we can't use L because L is always already used. We could do, what, M for millions? Sure. M of 30 minus M of 0. So how much was put out between this time? But the long story short is we can't solve the actual integral. So instead of solving, we're approximating. Instead of solving the definite integral, we're approximating. And if this is area, sweet, how do we approximate area? Riemann sums. Now, guys, are these rectangles or are these trapezoids? They didn't specifically tell us, but you should know. Rectangles or trapezoids? Triangles, not an option. On our area card, rectangles or trapezoids? Rectangles. Why? They didn't say trapezoids. You never do trapezoids unless they say trapezoids. Left, right, midpoint. They're all what? Rectangles. So rectangles have what area formula? Base times height, right? So all I need are bases and heights. And why am I only? Because how I do. Okay? So, first one, why 10? Why is AJ saying 10 if I'm saying base times height? Why 10? Change in x is my base. So what is the change from 0 to 10? Hey, what's the base from 10 to 20? What's the base from 20 to 30? Is it always the same number? No. But if they say equal, it should be. But when you're jumping in a table, you always have to subtract the two x's, subtract the two x's. Didn't this card say base is equal to subtracting the two x's, right? Base is delta x in your forever card. So then how do I find the heights? This is on your forever card too. Where do I go looking? I'll just say f of x sub I. Depends on what subinterval. So this first subinterval, you take the first jump. Second subinterval, take the second jump. Third subinterval, take the third jump. For the bases. For the heights, I need a y value. So, do I choose a y value on the left of the jump, on the right of the jump, or in the middle of the jump? Exactly what it tells me to. Not the left of the jump, not the right, but the middle of the jump. Middle of the jump. You guys see how I chose the middle and the middle and the middle? All you gotta do is plug and chug it to your calculator. What? This is a non-calculator question. Okay, cool. Isn't 10 just moving the decimal place? So won't it be 2 plus moving the decimal place, 26 plus 30? Isn't that going to be 58? You don't need a calculator for that. Okay, I heard 6 and 7. Just double checking. Do we still want 6? Someone say yes or no. Okay. Okay. Me too. But I also see down here a right sum and a left sum when approximating. There's my Riemann sums. They say a right sum and a left sum when approximating. Pause. Does it help for your brain to look? Eyes up here. Does it help for your brain to look and say area? Area. But you can't solve it. Okay, fine. Well, I could if I knew the antiderivative of 12 minus the but I don't. All I know is him. I don't know his antiderivative. Okay, fine. I don't know. Area. All right. I need to approximate. Rectangles or trapezoids? Well, what do they say? Right and left. Are those rectangles or trapezoids? Rectangles. Therefore, once again, I'm doing supposed to do left, and I'm supposed to do the right. 3 intervals. So I'm going to have an A1, A2, A3. I have an A1, A2. This is just another way of thinking about it. Well, that's weird. They're not even just asking for the right and left, though. There aren't 2 numbers. There's only 1 number, because what are they actually asking for? What's the big picture? Absolute value of the difference between the right minus the left. So don't I need to find the right, find the left, subtract, and then take absolute value? Okay, cool. They say I'm going between, look at your bounds, 3 to 12, right? How do I go to 3 to 12 in 3 jumps? 1, 2, 3. Base, we just said delta x. So base, what's the base of the first one? 5 minus 3 is 2. Base of the second one. And then 12 minus 8 is, whether you're doing the left or the right, or even if it was a midpoint, guys, well, midpoint would be awkward. You need to know something in between. But these bases, they're the same. Bases don't change. What changes for left or right? Height. So heights, remember what I just said a second ago? And make a note to yourself in a colored pen with a highlighter. Just because it makes sense right this second doesn't mean it will later. When we do Riemann sums, you can even make a Riemann sum forever card if you want. When we do Riemann sums, and we make a jump, right? Our heights are our f of xi values. If you want a left, if you want a right, you can even go to this card. Left would be f of x, the ones on the left for each jump, and right would be f of x on the right for each jump. So guys, between 3 and 5, 3 is the left one, right? For this jump, who's his y? 2. But for the right one, I'm going to use 5, whose right is 4. So this guy's starting at 2, whereas that guy's starting at 4. And now we jump again, right? Who's on the left? 4. Jump again. Who's on the left? 6. So you're going to have 4 and you're going to have 6. But for this guy, we start here and we jump to 6 and we jump to 4. If you're doing the y's for the left, you're choosing the x's on the left for each jump. If you're doing a right Riemann sum, you're choosing the x's on the right. And if we're doing a midpoint, what are we choosing? Middle. And if we're doing a trapezoid, we need 2 heights, right? So we're going to have height 1 and height 2 with the rest of our formula, true? And height 1, height 2 is going to come from f of the x on the left plus f of the x on the right. Is this making sense? Y values for heights. It just depends on which y values we use, and we know that based on the clues. And so we could go ahead and do something like, oh, hey, that's going to end up being 4 plus 12 plus 24, which is going to end up being 1640, I think, right? And then this guy's going to end up being 8 plus 18 plus 16, which is going to be 20, 34, 42. I believe the final would be 2. I heard 7. Do we still want 7? Give me a yes or no. Why are they giving me a definite integral? That makes no sense. I'm doing area. Right? Definite integral. How can it be found? Area. Okay. So, they don't give me. I have to do it myself. You have to do it yourself. So where am I going from? If you want, if you like it, make your own table. Can't I say that my f of x I'm trying to find the area under is sine of x? Right? Aren't I starting at pi over 2 and ending at pi? Right? And how many jumps do they want? 1! Uh-oh. Nope, they say 2. So I want to go 1 and 2. Well, if they say equal subdivisions, kiddos, what's halfway in between 90 and 180, or pi over 2 and pi? The 45, which is 3 pi over 4. You guys know this. If you have a calzone, remember a calzone is half a pizza. What's half between 1/2 and 1 whole? Talking about pies? Isn't 3/4 in between? Okay. Now approximate what area? Using rectangles or triangles? Sorry, rectangles or trapezoids? Ah, I'm sounding like you. Rectangles, they don't say trapezoids, it's a right. So area equals base times height, right? Coming from the right. What's my first base? No, what's between it? What's 3 pi over 4 minus pi over 2? What's 3/4 minus 1/2? Okay, if you don't like it, it's okay. Just do 3/4 minus 1/2. 3/4 minus 2/4. Isn't it just a quarter? There's a quarter in between. And how much is in between here? Another quarter? Good. So we're going to go ahead and say, okay, we have pi over 4 for our first base, pi over 4 for our second base. Now what do I need? Heights. If I'm going from the right, for my first jump, am I taking the y on the left, or am I taking the y on the right, or the y in the middle that's not there? On the right, because it says right. So I need this guy. Okay, well, what's sine of 3 pi over 4? Root 2 over 2. Then, for this jump, I need the guy on the right. What's sine of pi? Careful. Do we know the shape of a sine curve? Isn't that 1 pi? That's one way of thinking about it. And then where's 3 pi over 4? Oh, it's hard. It's not quite 1/2. But maybe some of you guys remember the cheater chart. 1, 2, 3. Where's pi over 4s? Right here. All students take calculus. All are positive. Sines are positive. Tangents are positive. Calculus is positive. It's calculus. Hopefully it's somewhat of a positive experience. Cosine is positive. Yikes. And we end up with, well, that's lame. He just cancels out. And we end up with this guy, which is what? Root 2 pi over 8. Oh, they don't even do that. Silly goofs. They just write it like this. So pi over 4 times root 2 over 2 plus 0. Sure, that works. All right, I've covered all the questions I've heard so far. Any other ones we have? Because what they're doing is they're actually kind of doing like a little baby formula where they're like, hey, it's equal subdivisions. So remember how I said, like, if it's equal, you can actually do a shortcut when plugging into your calculator. You can pull out the pi over 4, and then you can do what's the height of one plus what's the height of the other plus what's the height. They're just doing the shortcut and not simplifying it. But remember, if you ever see something like this where they haven't simplified and you have a simplified answer, you can always just multiply and see which one matches. Worst comes to worst. But yeah, that's why they did that. Anything else? Okay, it's totally fine. So what does that mean you get to do for the next 23 minutes? Oh, AJ, sorry, I thought you were going to say it out loud. 1D. Okay, if you guys want to look at it. If you need to just be working at this point because we've caught up to where you are, then please feel free to just start working. If putting in music, you focus on the calculus music. In just a moment, though, when I say it's work time, I'm walking around and taking away anything that's not calculus related. Just a warning. So we're on one. Hey, it's a table, yeah? It's a table of rates. I see dollars per day. Okay, it's a table of rates, dollars per day, kind of like derivative values, like specific ones. Okay, you're looking at 1D. Let the function be defined by Q of t be a model for the rate of change in the value of the stock. What are we talking about? R of t is the rate of change value of a stock in dollars per day over the 12-day period. Okay, so they gave us some specific values, and then they were like, by the way, you can actually talk about it as a function. So they're changing the rate to be a function instead. So it's like, work with the table, work with the table, work with the table. By the way, now I want you to work with an equation. Okay, fine. So I don't even think we really need the table, but just in case we do, I'll keep it here so I can access it. Okay. What value of t does the... Have I been speaking this language for a while? Yeah, but it's okay. You have forever cards. I know that this equation you might have never seen before, and you might have never seen an example yet this year that talks about stock, but I don't care because I know something you have seen. What have you seen in this problem? And not just rate of change. Rate of change, what should you be thinking? No, instantaneous. Instantaneous. Think of MVT, yeah? MVT card. CalcBC kiddos in a video yesterday referenced the MVT card, had me pulled up so that they could show the forever card in their video. MVT. What's the conclusion of MVT? If f is continuous and a closed, differentiable and open, then there is such that what? MVT, just not this problem, MVT. Okay, that's fundamental theorem of calculus. There is an MVT for integration too. That kind of has to do with that. Let's go back to MVT for derivatives. You're right, Christina. There is one for integration. Is equal to, yeah, f prime of c equals f of b minus f of a all over b minus a. In the wording of MVT, I say instantaneous rate, the prime, f prime of c, equals the average rate, f of b minus f of a all over b minus a. Some of you might want to label that better on the instantaneous equals the average. This is exactly what MVT says. So some of you need to go to the MVT card and make a note of the wording. MVT for derivatives. Your original MVT card, the words, not just the formula, but the words. Instantaneous equals, you guys see the average comes right next? They're saying solve MVT. Instantaneous equals average. An average, didn't they say between 12 and 0? So what are you supposed to do? Is this a calculator problem, AJ? If it's a calculator problem, kiddos, couldn't I throw this in my Y1? Wait. I was showing you calculator stuff yesterday because I've been saying it with words way too much recently with my calculator not working. Okay. With my calculator working. How would you simply, trying to avoid as many mistakes as possible, solve for this average? Put the function where? Yeah. Totally put the function into y equals. And so I would go ahead and, I'm doing my little shortcut of getting my fraction in, but I can do my 30t all over 1 plus t squared. How hard is it to put this function in a calculator? Not hard. What can I do with this function now that it's up here in my calculator? Go to my, what am I doing? Home screen it, right? Second quit. How do I find my vars? Yeah, y vars. Which we could do this vars button and then we could go ahead and go find the y vars function. But that's annoying. Is there a shortcut? Alpha trace. Or if you don't know, you don't remember, just do alpha, one of the buttons, and you can go through and find them. I can say, hey, what do I want to plug in? But guys, do you remember how yesterday I warned you if you try doing this in pieces, it can be dangerous? So I think instead of doing that, I would have put a fraction and I would try to plug it in all at once, yeah? And I would do y1 of, just like it says here, 12 minus y1 of 0. Do you see how easy this can be? It's just learning how to use your calculator. Which technically, we learned how to do y1s in the Graphing Calculator Handbook in pre-cal. Doesn't mean you remember it, though. So 6 over 29 can be our answer down here, right? But hold on, what do we need to set equal to 6 over 29? Can this find me the general equation of a derivative? No, it can only find me the numeric derivative, a derivative out of value. So what do I need to do by hand? Bottom d, top minus top d, all over bottom squared. I do need to find t. But I need to find t with the derivative. Does that make sense? Wait, why didn't I do the plus 10? Because the derivative of any constant is 0. Oh, I don't want to solve that by hand. It's gross. You're not meant to solve it by hand. Okay, so how do you solve it? 2 ways. One way is to make this y1 and to make this y2. I already have, I don't have either of them. I think I should clear out my y's and put in a new y1, a new y2. Guys, what graphical feature are you looking for if you're taking 2 functions and trying to find the equals? No? We know that, right? Where two functions hit, where two functions collide, where two functions intersect is when they equal. So we could use an intersect feature. If I were you in a colored pen, I'd be making a note of this. This is just how to use your calculator. You could solve with intersection. What's the other way? The other way is you could do y1 minus y2 is equal to, I could subtract this to the other side. Guys, wouldn't there be a 0? So I'd be using the 0 feature. Can anybody think of, and I've said it before this year, but I don't just want to give it away again, because maybe it hasn't stuck. Can anybody think of why it would be helpful to do 0 instead of intersection, even though they should both get you the same answer? Why would 0 be better? Where could the intersection be? Anywhere. Oh, zoom, 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 zoom. I don't know. I have to go find it. Where's the 0 going to happen? On the axis. I don't have to go looking up and out. And I might have to go looking over, but I don't have to go looking over and up and out. Now, the nice thing is I know from 0 to 12. So here's the cool thing, guys, and here's what I'm going to do in my calculator. I'm going to go ahead and throw this big old nasty derivative just the way he is, because I don't want to make any mistakes. I'm going to throw him into my y1. I'm going to go ahead and do my little fraction. That way, once again, I don't make any mistakes. I'm going to do my 1 plus x squared. Did you guys check my derivative? Did it look good? I hope so. Then I have my 1 plus x squared. Yeah, it's not t, but remember how my calculator does x's? It's okay. Oh, thank you, thank you, thank you. Yeah. I missed a t in writing the top. Okay, now it's good? Whoa, 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 whoa. Okay. If for any reason you'd already put this guy in here, then you could have put your, what is it, 39? Is that what I'm setting it equal to? Oh, 6 over 29. Wow, I don't know how I got that. 6 over 29. If it was something where you'd already put in the function and you're setting it equal to something, guys, you could go ahead and deselect. This is what I see more commonly. And you could do like what I did to show you notation. You could do, once again, your y1, your y bars, minus y2. I want to find his zeros, and I'm going to change my window to be 0 to 12. How come? And I know it's going to happen around the axis. I already see 1 0. I might be in a little bit of trouble if I have another one. Ooh, nope, it's a horizontal asymptote. I'm good. How do you find zeros? Second trace, 0 feature, right? How do you do left bound? Oh my goodness, I'm wasting time scrolling. What did I tell you yesterday? Isn't this 1? How about 0.5? Shouldn't that be somewhere over here? How about 1.5? Shouldn't that be somewhere over there? You can save time. My 0 would be 0.986. My place where the instantaneous equals the average will be 0.986. Why didn't I put 1.0? Why not put 0.99? Why not put 1.0? Why not put just 0.9? 3. Decimal, places, always. Why am I saying this? Even BC kids mess this up on the actual AP. Struggle. 3, unless they say to the nearest whole number. Otherwise, always 3. Okay. Kiddos, I'm timing out. I want you guys to have at least 10 minutes of work time because I'm also going to get you your mock APs soon. So I want to have everything ready for you when I give you your mock APs as well. Ready, set, work on LTF number 6 if you need to. And if you don't need to, go to LTF number 7, which we're taking on questions tomorrow. All right, guys, I'm about to hand out your mock APs. It's kind of going to be a bit of a beast. I'm not sure if I have enough huge paper clips, but I'll make sure to have a box of huge paper clips here tomorrow so you can get them all together for right now. Please just keep them all together in your information or in your folders. Hey, guys. I'm talking. I'm recording. I'm giving you information that's important. Okay, I'm about to give you your A multiple choice, B multiple choice, your FRQs with your Scantron. On your Scantron has the details of the grading as far as how many points you got from multiple choice, which are how many you got right times 1.2, plus how many points you got right from how many points you got from your FRQs. Now, remember, this mock AP you took a while ago, and some of you guys remember you lost points that you would have gotten otherwise if only you had known how to show it correctly. You simplified too much, you didn't put dx, dt's, etc. So some of your FRQ scores are quite a bit lower. I'm going to post in your Google Classroom. Remember, it has to be a secure place. I'm going to post the answer keys, including the multiple choice right answers, just in case the Scantron machine got off. You can double check that I really missed that many. You probably did, but you can double check. FRQs, the answer guidelines will be on there, and by the end of today, hopefully the videos from the CalcAB kids, the last group is taping today, will be on there as well for each of the different exams. Now hold on, each of the different exams, this is where you were to some degree. Where you are could be a totally different place, and how can you tell where that is? Taking the other mock AP and having it ready for us to go ahead and grade and taking it in a timed fashion and seeing how much you've learned, okay? But we also have quite a few things to figure out on the FRQs to get you more points. And also the scoring guidelines for the two are very different, but it's what the AP said. So one of them, a cap for a 1 to get to a 2 was a 35, and the other one was a 26. Very different, but that means the exams were different difficulties as well. So come grab it on your way out. Eurus, come on up. Rachel is gone, never mind. David, come on up. Who did not put their name on it? Rebecca, come on up.
Wait, never mind.
Ryan, come on up. Rachel just said is gone. Allie, come on up.
Go on. Thank you.
Michael, come on up.
Yeah, Michael.
You got this.
Yeah, Michael.
5. Definitely.
AJ, come on up. I can find you.
I think you're right. You probably will.
Patricia's gone. Christina, come on up. Ruth, come on up.
I just want to see. I just want to see.
Janelle, come on up.
Doesn't matter what it says. I just want to see what it says. Oh yeah, squad.
Grace, come on up.
Hey, Grace. Yeah, it's all of us
We'll have
left.
to see how the guiding thing went. Joyce, come on up. Everyone who took the second exam, yours was the harder
I told you.
weighting, but I think it was because it was the easier test. So we need to look at it and see. Thomas.
Terrible. What does that say?
So that's how many multiple choice you got right. How many FRQ points, which can be so much higher if we just figure out
Yeah.
what was going weird. So that's how many out of 108,
Okay.
which put you in the high range of the 1. Once I post it, you'll be able to see what the scoring is.
Okay.
For the other exam, that would have been a 2, but